Okay, so when you're looking at this problem right here, and you are inverting and multiplying, okay, so instead of dividing, we're going to take our fraction. The first fraction, I'm just going to factor everything in my first fraction and write it as it is. And then I'm going to invert and multiply. So here my 5t minus 20, which can factor out a 5. And then in my denominator, I can factor out a 4, leaving 5t minus 2. So this would be my factored form. I've inverted it and multiplied it. And now I'm going to cancel any common factors. So the t minus 4s can cancel, and that's it. Nothing else cancels here. Okay, so I get my solution. 4 times 4 is 16 times 5t minus 2 all over 5 times 5 is 25 times t minus 2. Okay, so here is my simplified form. Nothing else can cancel. Okay, when I go to look at my domain restrictions, I have to account for any canceled factors down in the denominator as well as any uncanceled factors up here. Well, in my denominator, I see that t can't be a 4 based on this factor. That's not apparent in my simplified form, so I include that as a domain restriction. But what I have now is in this numerator, I have a factor that did not cancel. Okay? The reason we need to restrict this from the original domain, this cannot be, the value that gives this factor a 0 cannot be used for t, because if it did, then in this form right here, this second fraction, it would give you a 0 in the denominator of that fraction before you invert it. So I look here to find the 0 associated with a binomial that has a leading coefficient other than 1. I take the opposite of the constant, 2, divide by the leading coefficient, 5. So 2/5 would be an additional domain restriction.